Fine, guys, let's start with today's session. Today, mostly we are going to see the workflow of machine learning. Okay. But before that, let's step one step back and see one of the important thing in the ML types. Okay, in types of ML, and then we'll come back to this. Okay. So see, the other day we were discussing about types of ML, right? Over here, yeah, over here. In the machine learning types, we have seen supervised, unsupervised. Okay. So if I speak about this, okay, so ML, fundamentally you have supervised, okay, and unsupervised. Okay. In this supervised, we have further what do you say, categories, okay, which are mentioned as okay, regression and classification. And most of the machine learning problems, okay, which we will be solving, okay, will be falling under supervised machine learning algorithm. Fine. So as we have seen, supervised is further divided into two. One is regression, one is classification. Now, what is the difference between these two? Very simple. First of all, what is supervised machine learning? So if you remember, we understood that supervised machine learning is that type of machine learning algorithms where you remember this, where we have both input, which are called as features, and also output, which is called as label. Agree? We'll be passing both input and output to the model. Fine. And once the training is done, we are going to do the predictions. And the fundamental purpose over here is to train the model so that we can use it for some predictions. Okay. So unlike unsupervised, in unsupervised, what was our goal? Just to group the given data into certain categories or certain clusters, which is also called as clustering. Agree? But in supervised, the main goal is to train the model so that we can use it for some predictions. Okay. So for the model to give some predictions, first of all, it should be trained. Agree? Now, first, it should be trained in the sense what it should be exposed to both input and output. Fine. Only then it will be able to understand the relationship between these two. Fine. So we'll be passing both X, which is features, and also Y label. Okay. Feature and also label will be passed in supervised. Okay. Now inside this we have further divisions of regression and classification, and the difference between these two is very simple. Okay, so it's only dependent on this y variable. Okay, it's only dependent on this y variable. Now if this y variable, okay, if this y variable is continuous, okay, then it becomes regression, or y is categorical, then it becomes classification. That's it. Now what is continuous? It's a numeric continuous value. That means what? 4, 4.5, 5.6. Okay, so any value is possible. Fine. So we have seen, right? So types of data. So what is continuous value? What is numeric value? What is categorical? Remember? So it is related to that. Fine. So when if the y variable is continuous in nature, okay, then it is regression. Okay, that type of all problem will be solved using a regression problems. Okay, and if the y variable is categorical in nature, okay, if the y variable is categorical in nature, that means what? We have only few categories. As an example, iris dataset. Okay, what is a output y label in iris dataset? Only three: Setosa, Virginica, versicolor. Agree? Apart from these three, there are no other possibilities in output y label. Agree? So obviously that is categorical in nature. So when we have y output y, or let me call it as label, right? Okay, or it's usually called as target. Okay, it's feature and it's called as label or also target. Target feature variable, target variable. Okay, so when the target is categorical in nature, fine, so it is called as classification. Okay, it's called as classification. So that means what? We are going to classify the given input into one of the given category. Agree? But whereas if the output is, the target is continuous in nature, fine. Obviously, when it is continuous, it will be in numbers, right? It will be in numbers, fine. So it is considered as a regression problem. Is this clear, guys? Any doubts?
Clear, Santosh.
Okay. So, but here you should be careful that just because the output, okay, just because the output is numerical in nature, you should not blindly consider that as a regression problem. Okay, because why? For example, let's say I have a data set where my, okay, where my output is just to predict like one of the three. Okay, so let's say it is ranking. Okay, so rank 1, rank 2, rank 3. Fine, rank 1, rank 2, rank 3, my output. Okay, I don't know what is my input. Okay, whatever it could be, but the output is in this way, 1 or 2 or 3. Fine. So now, even though this is looking as, these are looking as numbers and numerical in nature, fine, but still you cannot tell this as a regression problem. Why? Because these are clearly categories. Agree? Apart from 1, there is no other value possible. You cannot have 1.5. Okay, so but in regression, for example, if you take an example of house price, okay, so you take the house price example, find the what house price could be anything, right? Anything in the sense what, like it could be 40,000, sorry, 40 lakhs, or it could be 40 lakhs 3,000. Agree? Or any value between 40 to 50 is possible, so it's continuous in nature. Fine, you cannot like divide them into categories because there will be extremely many categories. Fine, so any value is possible between given two values. Fine, if you say the house, the minimum value of house is 10 lakhs and maximum value is 100 lakhs, so any value is possible between these. Fine, so you cannot divide them into categories. Fine, even if you want to divide, you will have like infinite number of categories. Fine, so obviously this is continuous in nature. Fine, but over here, even though these are numbers, these are not continuous in nature. These are what? These are discrete. Fine, that means what? They're only fixed categories, fixed values, discrete, continuous, you can call them as. Okay, fine. Over here you have 1, 2, 3, just three, only these three values are possible. Fine, so obviously this is a categorical nature. Now this will become a classification problem. Fine, and if it is direct categories, like let's say if you are working on election data set and you are going to predict which party is going to win, so obviously the categories will be, output categories will be, let's say BJP, Congress, or Aam Aadmi Party, etc. Fine. So there are only fixed categories. There are nothing in between values. Okay, either this or this or this. That's it. So obviously there is a classification problem. Fine. But if you're working on some, as I mentioned, like house price, or let's say your salary, fine. So that is a continuous, because salary, any value is possible, right? It could be like 40,000, 40,333 rupees dot some paisa. Okay, like that. Okay, what is the loan amount? Fine, and etc. And even the count of people. Fine, so how many people got affected in some pandemic. Okay, so all these are continuous values. Fine, so that is a, those are two categories in supervised machine learning. And as I said, most of the problems, okay, most of the time which we spend in ML is will be under supervised machine learning problems only. Fine, and this is obviously a separate category. Fine, unsupervised video clustering. Fine. Now, any doubts, guys? Any doubts still here? Okay. So now, just to give an idea. So in regression, we are going to see um an algorithm called as linear regression, guys. Okay, it is the fundamental algorithm. Okay, which I think I have already introduced in okay, briefly. Fine. So we are also going to see in depth from mathematical point of view, from visualization point of view. Okay, so and after this is one of the most famous and also fundamental algorithm in regression category. Okay, and also over here you also have different types of regressions. Okay, L1, L2. Okay, which is also called as lasso. Okay, and ridge. Okay, and also there is a, when you combine these two, what do you get is something called as elastic net. Okay, so lasso, ridge, elastic net. So these are different variations of regression. Okay, the fundamental concept is regression. Okay, so but only there will be quite variations in some parameters. Okay, we will see what are those and why we need to introduce when we already have basic linear regression. Why, what is the need to introduce some other parameters so that we have different types of regressions we are going to see, and that will be very logical and interesting. Okay, so mainly in regression we are going to have this. Okay, direct regression. Okay, but there are some algorithms. Okay, so let's switch to classification. We'll again come back to regression in a minute. Okay, so in classification, the one of the first algorithm which we are going to see is called logistic. Okay, logistic regression. Okay, so even though the name is regression, right? Don't get confused. This is a regression algorithm, but this is a classification algorithm. Okay, so this might be a small tricky question to test you, but remember, logistic. The name is logistic regression, but this is not a regression algorithm. This is a purely classification algorithm. Okay. After that, you have something called as KNN. Okay. Then you have Naive Bayes. Okay. Then you have SVM, support vector machine. Okay. This is K nearest neighbors. I think I have talked briefly about KNN, right? And this is support vector machine. Fine. And then you have something called as decision tree. Okay. Decision tree. And from this decision tree only you have segregation of bagging and something called as boosting, guys. Okay, and this type of bagging and boosting is combinedly called as ensemble. Okay, sorry for the bad handwriting actually. Okay, ensemble learning. Okay, so what is ensemble learning? The concept of creating how this bagging and boosting are created from single decision tree is called ensemble learning. Okay, and over here you have bagging and boosting, and inside this bagging you have something called as random forest. Okay, and over here in boosting you have the first one is called as ADA boost. Then you have what do we have? We have
XGBoost.
who's this? Sirisha. XGBoost. Okay, and what do we have? Actually, in boosting there are many algorithms. We have cat boost, we have extreme gradient, and sorry, there is one more gradient boost. Okay, before this XGBoost, we have gradient boost. Okay, fine. So overall, these are the algorithms that are currently okay, that are currently in this machine learning field, I would say, in supervised machine learning, which most of the people are using, and these are the most famous algorithms as of now. Okay, and how many guys? Okay, 1, 2, 3. You can say 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, and in clustering, sorry, in unsupervised, you have, I would say, 2 or 3 algorithms. Okay, one is k-means, hierarchical, DB scan, okay, etc. We'll see when we discuss this, right? But fundamentally in supervised machine learning, so these are the algorithms. So as you can see, there are the most of the part is inclined towards what? Inclined towards classification. Fine. Most of the problems which we solve is also falls under classification. Okay. But here, just to mention, there are few algorithms which also offer regression features. Okay. So using, you have in decision trees, it's also called, actual decision tree is also called as CART. Okay. Classification and regression trees. Okay. Classification and regression trees. So in decision trees also, you have decision tree classifier and decision tree regressor. Okay, that's why I'm writing over here, decision tree regressor. Okay, so once you have this decision tree as regressor, so mostly all these also have regressors. You have random forest regressor, AdaBoost regressor. Okay, you can also do regression. Okay, you can also use regression, these algorithms for regression problems. Fine. So this is just an overview, guys. Okay, so just to give an idea, like which algorithm, I think you might have already heard this algorithm's name somewhere. Okay, but this is to give you a clear picture, where does this fit into. Okay, so exactly what type of algorithm is this. Okay, because choosing the right algorithm, or at least right category of algorithm, is very, very important. So otherwise there is no point of training the model. Fine. So I hope next time when someone speaks about classification, this segregation will come into your mind. Okay, the first thing is, it will be uh, when they say the supervised machine learning algorithm. Fine. So obviously you need to remember that it is divided into two parts. Okay, one is regression and classification. Both are, see, I'm repeating again, both are supervised. That means what? In both of these scenarios, you are going to pass X and Y. Okay, that is not going to change. Okay, you are going to pass, you're going to pass, oh, 1 second, sorry. Okay, you're going to pass both X and Y. Here also you're going to pass X and Y. Okay, that is not going to change. Whatever the supervised algorithm features and conditions and rules are there, that will be applied to all of its categories, like regression and classification, everything will be applied. Okay, the only difference is here the output target variable will be continuous in nature, and here the output target variable will be categorical in nature. That's it. Okay, and so these will be the categories. And whenever they say, let's say when I say next time when I say decision trees, okay, so you should, when I say decision tree, specific decision tree classifier, okay, that will be falling under classification structure. Okay, and when I say KNN, so obviously that will be a classification algorithm. Okay, so to choose which type of algorithm is very, very important, guys. Okay, so fine. Any doubts, guys? Let me pause here and just let me know any doubts, general or casual, or any doubts which you have in your mind, not necessarily from this class, or in before, if you heard something about these algorithms and you have any doubts, small, big, silly, any, that's fine. You can unmute yourself and ask.
Sir, decision tree, regression, and card belongs to classification, sir. Or else,
No, that is a
with this.
general. So that's what I'm saying. Decision trees are generally called as CART algorithms. That means what? It is saying that classification and regression trees. Okay, this is general. Okay, so over here you have decision tree, you have decision tree classifier. Okay, and also you have decision tree regression. Okay, this is general name. There is no model by the name CART. Okay, but you have a model name called as decision tree classifier. Okay, and there is a model name called as decision tree regressor. Okay, so this classifier will fall here and this regressor will fall here.
Okay, sir.
Okay. Others, all good?
Yeah, Santosh.
Okay, fine. So now, since we have an understanding now at this point, what all we know, guys. So we know what is machine learning, and we know what are the at high level what is different categories of machine learning, right? Supervised, unsupervised, semi-supervised, reinforcement, right? So, and we understood the as of now the things which we are going to focus on are supervised and unsupervised. Fine. In unsupervised we have regression classification. Fine. And sorry, in supervised. Okay, did I say unsupervised? Oh, sorry. So in supervised we have regression and classification. Fine. And there are further categories and algorithms. Fine. And in unsupervised there is no separate categories this unsupervised is divided into, but we have direct algorithms. Okay, fine. So, and these are the algorithms, guys. Okay, so just to if you are already guessing, so these are the algorithms. Okay, each of this algorithm, let's say linear regression. Okay, so this is a machine learning algorithm. Fine. So that means what? So there is some max involved in this. Okay, and there is some logic over here. So that means based upon I would say what does an algorithm mean, guys? Okay, so it is a most of the algorithms are just max, right? So inside this what happens, so we will see what is that max. Okay, so based upon certain calculations, okay, and some mathematical calculations, I would say, so we are going to derive what a line. Okay, in linear regression, what is a model? Fine. So a model is a output of a algorithm. Fine. So just to give a clarification between this, what is an algorithm, okay, what is a model, right? So I would say a model is an output what we get finally, okay, from an algorithm. Okay, but what is algorithm over here? Fine, it's just max. Okay, and over here we have something called as gradient descent. Okay, so we have gradient descent algorithm. So inside this linear regression, okay, we will see. I don't want you to scare and confuse with a lot of words. Okay, but ultimately the most of the algorithm is filled with max. Okay, so once that is done, and based upon the calculations what the linear regression needs to do, and once it is done on the given data, it will come up with a line. Fine. So that line is the model. Okay, that line itself is a linear regression model or machine learning model. Agree? So like that, in every algorithm you are going to get one model. Fine. And every approach is different. Fine. See, guys, if you are guessing, so these are all the classification problems, sorry, classification algorithms. Now, if I say I have a iris data set, right? So iris data set, what is it? A classification or regression problem? Obviously, it's a classification. Why? The output is categories, just three categories: Setosa, Virginica, Vesicle. Right? Now I have these many classification algorithms options. Fine. So everything over here, everything will work for a classification. But now, based upon my data, I need to choose which algorithm is best. Okay, because you cannot randomly take one algorithm, and because see, even if you take any algorithm you are going to get some accuracy. Okay, that's fine, but that is not the goal. Our goal is to have the maximum accuracy, and importantly our goal is also not to fall into these problems called as what, overfitting and underfitting. Fine. So we are going to see what are those. Okay, but overfitting, because for example, if you take a small iris data set and if you apply directly this very powerful algorithm called as XGBoost. Fine, XGBoost. Now what happens? It gets overfitted because XGBoost is an extremely powerful algorithm which can handle complex data sets. And if you are just giving a small um, iris data set, okay, it is going to overfit. That means what? It is going to learn the complete training data set. Okay, so I'm not going into like depths of what is training testing data set, so which we'll be discussing in a moment in the machine learning flow. Okay, so but there will be certain problems. Okay, that's why it is important, okay, to understand each algorithm and its background and its max, and also its approach, how it is going to divide, so that you will get an idea which algorithm to use. Okay, and this is where, okay, you will get differentiated from others in interviews. Okay, because coding is not a big deal in ML. At least in the beginners level, coding is literally nothing, guys. Okay, so I can show you, if possible, tomorrow I will show you. A complete machine learning algorithm can be developed in just less than 10 lines. Okay, sometimes 10 or less than 10. Okay, some 7 to 8. Okay, because what is there, guys? Okay, in one step you are going to see, guys. Okay, see, for example, okay, first you will just import the data. Okay, data importing will done, and let's say 2 and 3 steps will be data pre-processing. Okay, if for sample pre-processing. Okay, just simple pre-processing. Okay, data pre-processing. Okay, fourth one will be the, if at all you want to you know uh, uh, just you want to do some feature selections. Okay, and fifth one will be the model. Okay, model, here only you will import, let's say you have some imports, right? So you will import all the required models over there. Okay, here you will do the model dot fit, that means model will train. Okay, and next thing will be you will model testing you will do. Okay, and seventh, model accuracy you will get. Okay, and if it is good, you will do model predictions. That's it. Less than 10. Okay, sometimes let's 10. And the code is also very, very simple, all one-liners. Okay, if you just say model dot fit, the model gets trained. If you say model dot predict, the model predict. Okay, the code is nothing. You will not face any difficulties in the coding part. Okay, at least in all the algorithms I have shown you, right? So all these algorithms coding part is very, very simple. Okay, no difficulty at all, I would say. Okay, so that's why they're not going to focus on coding part. Okay, they're going to focus on the background. Okay, if you say decision tree, okay, you need to understand what is a decision tree. Okay, how it's going to classify. Agree? So what are these algorithms going to do, guys? They're going to classify. Fine, everything is going to classify. Okay, each and every algorithm is going to classify. So what is the difference between between each of them? The approach, right? Logistic regression will work in certain conditions and it will classify, the model will be different. Okay, in logistic regression also the model will be a line. Okay, the KNN is different type of classification, and as I mentioned, it's an instance based algorithm. Agree? There is no model that will be generated in KNN. Okay, Navy base is something different, SVM is something different, decision tree is different. Okay, so each of the algorithm. Okay, so when we are discussing, fine, so we'll be discussing the max, we'll be discussing the approach, we are going to see different examples. So your goal is to understand the background of each algorithm. Okay, so background of each algorithm, max of each algorithm will be very important. Okay, because those are the areas where usually the questions from the interview will come. Okay, so if you're going for an interview, obviously they'll definitely ask, they'll ask, first question will be, they will ask what is your favorite machine learning algorithm. Okay, they will ask you to choose one of the algorithm. Okay, and based upon that they will start digging. Fine, so why do you choose this particular algorithm, what is the max, etc, etc. Okay, so have grip on each and every algorithm is very, very important. Okay, coding is, as I said, it's not that difficult. Fine, cool. So now once we have that, no, so now let's try to jump into machine learning flow. Okay, ML. Okay, so usually I think we have SDLC, right? Software development life cycle. Okay, similarly you also have machine learning development life cycle. Okay, MLDSC. Fine. So usual software, like if you take any Java or some other software, so they follow this approach, software development life cycle. It's also called as a waterfall model, top to bottom they call something, right? Yeah, in our ML, so we have machine learning development life cycle, MLDLC. Okay, so over here, any algorithm, right? Any algorithm you take, this will be the structure, these are the steps you need to follow. Okay, so that you will cover end to end. Okay, so you cover end to end steps for that given algorithm. Fine, so this is not into any specific algorithm. Okay, but this is a steps, okay, for any algorithm. Fine. So over here, if you see, yeah. Okay. So let's start. So over here, the first and foremost step you are going to have is what? Is, just give me a second. Okay, fine. So the first step is going to be the data collection, guys. Okay. So the first step is going to be the data collection, obviously. Fine. So this data, most of the times it will be in the CSV format. Okay. Most of the time it will be in the CSV format. Okay. And most of the times the data will also be readily available. Okay. At least in the beginner stage, guys. Okay. If not, you might pick it from website or pick it from some other API. Okay. Fine. But most of the time you will have it in the CSV format. Okay. So you are going to collect this data. Okay. And you are also going to import the data. Fine. So you have data collection and also import. Okay. So you have your data set in your platform, that either could be, let's say, notebook, Jupyter notebook, or PyCharm, etc. Fine. So you have the data. And once you have the data, okay, once you have the data, fine. So, and you have data preparation, fine. And in this data preparation, you have some other steps also. I think this diagram looks like it's a very high level diagram. Okay. But let me search for some other diagram, guys. Okay. This diagram is also true. Okay. But it is having only few steps. Okay. But let me search for machine learning. Actually, there was one very good diagram. I lost that image, but let me quickly find it, guys. Just give me a second. Mm. Which shows the division of training data and also test data. I think, yeah, this should also work. Engineering. Fine. So let me just, okay, let's use this solver. Okay, fine. So over here, if you see, obviously the first step is going to be data collection, guys. Okay. So once you have the data collection and data importing, okay, and once you are done with that, okay, there will be some steps involved in the data cleaning. Okay, you are going to clean the data. What does it mean? So you are going to work upon missing values, okay, and outliers, fine, some noise detections, etc., etc. You are going to clean the data, fine. So now once the data is clean, okay, now once the data is clean, you are going to do some feature engineering on this. In feature engineering, what you are going to do? You are going to fundamentally you are going to understand different things about the input and output, and also each individual feature also. That means, let's say you're having x1, x2, okay, let's say x5, fine, and you're having a y variable, fine. So you're going to understand the relationship between each individual variable, okay, each individual feature and output variable, okay, or target variable, fine. And also you're going to analyze each of these individual feature. Okay, what is the fundamental feature engineering means? You are going to do some engineering on the each individual feature. That means you will take each and every feature and you will do some analysis. Okay, so you will see the distributions, and also you will understand. Okay, so if you need to do some scaling on each of these features, okay, or if the distributions are very different from the output variable distribution, and if there are any correlations between the input and output, okay, because if you have seen either in regression or in the classification, we are doing some predictions, right? So obviously the output is completely dependent on the input, fine. So if there is no relationship between these two, so there will be no results. That's why first of all you need to see if there are any relationship between these inputs and output, okay. And if at all there is relationship, then what is strength of strength of those relationship, okay. Because if you have like 10 or 10 input features, fine, so sometimes it is not helpful to use all the features, guys, okay. So you might need to drop, so then you to take a decision like which particular feature needs to be dropped, fine. So you will understand it in the feature analysis, fine. So you will understand what is the contribution of each and every individual feature in the prediction, fine. Ultimately our goal is to do predictions, fine. So our goal is to give output when you give certain input, fine. So for that you need to understand out of these 10 features, what are the topmost five features, fine. So which are contributing in giving the predictions, fine. So those and lot of EDA things you are going to do, okay. In EDA, what do we have, which is called as explorative data analysis. You are going to drill into, as I said, see, while we are doing, you will be understanding a better way, but based upon the scenario, you will be doing many things. For example, you are going to club two columns and make it into one column, okay, if there is a requirement, fine. If you think both are giving the same meaning, so you can club two columns into one column, or sometimes you might split one column into different column, or you might create a new column from the existing column, agree. So these type of things you can perform, so okay. And apart from that, as we have seen different, we will see the correlations, okay, and all the graphs which we have studied, okay, stats, right? So that will be mostly used over here, okay. In the feature engineering stuff, that will be used, fine. So the matplotlib pair plot, join plot, okay, box plot, okay. So for the box plot, you will be using for the this individual analysis of each feature, okay. So for x1, x2, x3, so like individual analysis. And to understand the overall picture, you are going to use the pair plot or join plot, fine. So and then you are going to also see correlation plots, okay, to understand the correlation strength of input and output, fine. So then once you, okay, reach that level of finalizing which features to use, okay, and understand, okay, what is the nature of each and every feature, okay, then you will be good with this step, okay. Here for the data cleaning, you are doing at the whole data level, okay, but after that in the feature engineering, you are going at each individual feature level, fine. Are we good till this point, guys? Are you guys on track?
Yeah, Santosh.
Okay, fine. So after that what we are going to do here is you are going to train a model, guys, okay. You are going to train a model, okay. But now here in training the model, okay, so you have a very important step that needs to be noted over here, okay. Now see, guys, just give me a second. Yeah, sorry guys. So now what do we have, guys? So we have the required features, fine. So once you have the required features, what is the next step? Obviously to train a model, fine. So based upon your model understanding, okay, based upon this model's understanding, you are going to choose a model, fine. So fundamentally, the moment when you look at the data, you will get a clear idea what type of algorithm you need to use, whether it is a classification problem or whether it is a regression problem. Okay, the first step, how based upon the target variable you are going to decide. Do you agree?
Yes, sir.
Agree? Fine. So based on the target variable, whether it is continuous or categorical, you are going to decide which type of algorithm to use. Okay, where is a regression classification. Fine. So now let's say it is a classification problem. Fine. So then based upon your data, like what do I mean by based upon your data? How many categories you have? Okay, the output. See, I said output is categorical in nature. Fine. But how many categories? It can have just 2 categories, 3 categories, 4 categories. Fine. Based upon that, fine, and based upon your features, fine, you are going to decide which type of algorithm to use, fine, because logistic regression, for example, okay, logistic regression has certain condition, guys. Okay, this is very, very important. Each algorithm will work under only certain conditions, okay, under certain conditions, fine. So because for example in this in the linear regression problem, if I just because you already have a small idea, so in that algorithm what happens is, what is the basic thing that is going to do? It is going to draw a line, okay, it is going to draw a line, fine, so that it is going to capture the pattern whatever that is available, fine. So this has certain conditions that the how the data should be present, okay, so only under those conditions this will work better, okay. Otherwise there is no point of using linear regression, okay, because if the data is completely scattered, okay, if the data is completely scattered, okay, like this, so it is very much difficult for the linear regression model, okay, to capture the meaning of most of the points, fine. So similarly for the logistic, for example, even for logistic regression also, logistic regression, just to tell you here, here also the model is line, okay. So here also the classification, okay, see guys, what is logistic regression? It's a classification algorithm. Classification algorithm means what? It will classify. How it's going to classify? Here also the model will be line, okay. That means what? So I'm just giving you a brief, okay. It will just say, it will divide using a line, okay, and it will say these are class 1 category, one first category, these are some second category. Agree? This is what a logistic regression will do, okay, at a very high level, okay, just as an idea. That means it will divide the categories. What is the job of it? Just to divide the given data into different categories, okay. Sorry guys, sorry, just I'm getting called. Yeah, so sorry guys. So I was saying the logistic regression model, okay, which needs to divide the given data, so it is going to use a line, okay. So obviously the nature of the data is important, agree, because if at all my one category, okay, my category okay, into and place, okay, if at all my, when you see the, okay, data, when you visualize the data, if at all my data is in this way, they're scattered in this way, okay, so obviously it is very easy for a logistic regression model to divide like this, okay. So because it is going to divide by line, obviously it can divide, okay. But if that is not the case, okay, if that is not the case, okay, so if the data is like this, okay, for example you have into plus into, okay, so you cannot clearly divide it with the line, agree, because if you divide over here, okay, you have here into and also place here, that means you have category 1, category 2, here also you have category 1, category 2. This is not a perfect classification, Getting guys? What when we say classification, what is the goal? When you should be able to say with some conditions, okay? So you are going to clearly segregate the category. Okay, this is completely one type of category. This is other type of category. Okay, there should not be overlapping. You cannot say this could be category 1 or category 2. Then there is no point, right? The whole point of doing all this is to give exact prediction. Okay, the machine learning algorithm cannot say this can be category 1, or sometimes it can also be category 2. If this is a prediction which you are getting from machine learning, does that make sense? No. Agree? So it should be exactly one type of category. Okay, that's why the choosing the algorithm is also very, very important. Okay, because each algorithm will have certain conditions under which it will work. Okay, and that is very important to understand, because if at all you are using logistic regression for this type of data, it fails. Fine, it cannot properly classify because it does not have those training. Okay, logistic regression is not trained for this type of data. Obviously, if we use for that, it will fail and we will suffer. Agree? So that's why understanding the data is one thing and understanding the algorithm is other thing. Okay, then you need to combine these two both. Fine. First, you should have clear idea what type of data. Okay, what is the nature of data? What is each individual feature? What is the relationship between input and output? And what is the distribution and how it is distributed in the space? Fine. Are there any overlapping between the categories? Okay, or they are clearly like segregated from each other? Okay, this type of idea you need to have. Once you have that, and once you have the idea whether it is a regression or classification problem, then you need to understand and think about each of the algorithm and get taken decision like which algorithm will be the best algorithm for my data. Okay, and most of the time, having said this, I'll also mention most of the time it is not any one type of algorithm, guys. There is no rule that okay, if this is a data, decision tree works best, if this is a data can work. No, that is not the case. Okay, you can take a good guess, okay, based upon your understanding and learning. Okay, but most of the time what happens is we try with multiple algorithms. Okay, start with one, but and also it's not blindly. Okay, see, you can do mistakes, but you should not do silly mistakes, guys. That means you can, I mean, okay, for this type of data, okay, for this type of data you can use logistic regression. Okay, because it is very clearly divisible by a line. Okay, and also you can also try with decision trees. Okay, you can also try with random forest trees. Okay, regression problem. Oh, sorry, classification. Okay, random forest classifier. Okay, because logistic regression is giving some accuracy, then you can go to decision trees and you can go to random forest. Okay, those type of things. But you should not blindly use logistic regression over here, because the nature of the data itself does not support logistic regression. Okay, these types of mistakes you should not do. You can experiment with as many models as you want, but you should have a justification why you are using that model. Okay, why you are using these many models? Okay, to get more accuracy or to reduce the percentage of overfitting. Okay, all these type of idea you should have, but fundamental mistake you should not do. Okay, that means what? Using a completely, okay, unuseful data for our unuseful algorithm for our data should not be used. Getting guys?
Yes, Santosh.
Yeah. But is it too much, guys? Are you guys understanding? Okay, I understand this lots of theory. Okay, because the initial class will be a lot of theory before we get into max or algorithms or feature engineering or algorithms. But this is also very, very important. But let me know, like, are you really on track understanding, or is it getting mixed up, confused, or what? Honestly,
I mean, for me, it's like taking so much input, kind of.
so much input.
I mean, yeah, so much data, right? Yeah, different,
Oh,
different.
okay, okay. But is it? Are you feeling
Yeah,
difficulty to understand, or
yes.
is it fine?
No, but kind of little confusion. So I mean, I think I need to
Okay,
go
okay.
through it again. Yeah,
Acha,
that's
acha.
it.
Okay, I
It's
advise you
like
to go through the class.
starting days of stats, same kind.
Acha, acha. Okay, okay. So I advise you to once go through the class again and make some notes. Okay,
Yeah.
fine. Others? For me, I understood good, sir. Sirisha is saying. Okay. Meghana, are you good?
Yes, sir. Understand.
Okay. Because I think most of the these things, it might be covered, right, in your college. Okay. So fine. Now, guys, now there is a, I hope you guys are not going to college, right? So we can continue, right? Okay.
Yes, sir.
Okay. So now see, guys. Now we understood the algorithm. I mean, we understood which algorithm to choose. Assume that, okay, we got the data, we have cleaned the data, we have done some feature engineering, and also we have decided which algorithm to use. After that, there is a very, very important concept, okay, over here. It's called train test split. Okay, this is very important, very interesting concept. Okay, so over here, what happens is, let's see, guys. Now, what is going to happen over here is, let's say you are having a data. Okay, let's say you have your complete data. Okay, now you're going to, let's say if you're using this to train, you're done the cleaning, everything, feature engineering is done. Okay, now the data is completely in the required shape and form and very ready to be used for any model. Fine. So over here, now let's say you have also used some ML model. Okay, this is some model. Okay, now there are, let's try to understand it from basic level. Okay, now let's say I've given my data. I've given some data. Okay, everything is done. I've chosen the model also. Now, if I want to use the data, if I use the whole data for training, okay, if I use the whole data for training, what happens? Okay, we'll try to understand that. Okay, so let's say you are using whole data, 100% of the data, 100% of the data. Okay, you have used for the model training. Okay, so the model got trained. Fine, the model got trained. There is no issues in that. Now, if I want to do testing, okay, over here 100% of the data, what I have done the training. Okay, so this is very, very important step, guys. Okay, so and I also ask you to just stop me if you're not understanding. Okay, so you don't miss any step over here. Okay, it's very, very important. Okay, because every algorithm we are going to discuss, right? So it will follow the same step. Okay, so general steps you should not neglect any time. Okay, because it will be applied to every algorithm. Okay, if you not understand any particular algorithm, that's fine. You can again go back, but general concepts, if you are not clear, okay, it will impact every other algorithm. Okay, so focus. Now I'm saying you have data. Okay, now while training, okay, first you need to train. Okay, while training, if at all I have used all the 100% of the data, the model gets trained. That's fine. But is my goal is to just train the model? No, my goal is to prepare the model so that I can use it for certain predictions. Agree? I can use it for some predictions. This is obvious. Agree? I want to train the model so that it can be used for some predictions. But I don't have data now with me. Whatever the data I have got, I've used it for training. Now I have zero data left. Okay. Now for the before predictions, okay, before predictions, there is something called as testing. Okay. So predictions, it can happen with any data. That means if you're very, let's say you have generated the model, okay, and if you hand over it to, let's say it's related to some bank, okay, bank want some ML model you have generated, and you can submit them the model. They will do some, they will start using it on the live data, okay, on the regular customers data. Okay, that means what? The data will be hitting the model and model will give some predictions. Okay, so predictions can happen, but before giving it to the bank, what you need to do? You need to test your model. Agree? You need to test your model. Okay, so over here you are going to have your model testing. Okay, testing you need to do. But the problem here is there is no data available with me. All my data is used by training phase only. Okay, but if you think that you can use the training data only for testing also, okay, that means what? You have used your data and you got some ML model. Okay, And on this ML model only, see, on this ML model only, for training also you are using training data. Okay. But while testing also, that means to test the model. Okay. To test the model, also you are using training data. That is completely fine. That is completely fine. Okay. But what's the point over here? See, if you're thinking how we are using both the data for training and also testing, here you need to understand the very fundamental point. For a machine learning model, when you pass certain data, fine, I'm calling it as training data. I'm passing the data. There is no guarantee that it is going to understand the whole pattern. Okay. There will be a lot of factors. What type of algorithm you're using, what type of data that is, okay, etc., due to n number of factors. It is going to understand certain pattern. Okay. And technically speaking, there will be what is model, it is just weights. Okay, it is just numbers, weights inside the model. If you see, I will show you. Okay, so it is just weights. Okay, it is just understand patterns in some mathematical fashion. Getting? Now, when I'm passing training data, from training data, it will understand certain pattern and it will, according to the algorithm, and the model will be generated. Okay, now let's say model is intelligence. Fine. Now using this, now this is intelligence, right? Now once it is trained, the model, now it is not related to any type of data. Okay, only till training it is related to training data, because it is getting trained from training data. Now once my model is trained, I have the model. Now it is independent of any other data. Now it's the only job of this model is, you give me input, I'll give you output. Okay, the only purpose of this model now that is generated is, you give me input, based upon my training I'll give you output. Okay, based upon my training I'll give you output, which is called as predictions. Okay, because I got trained with both input and output. Now and I'm using certain algorithm, I have some max calculations. Okay, I understood the pattern that is given for me. Now I am generated. Now give me input, how many inputs that are trained. Okay, while training, if you use 5 inputs, while doing testing or doing predictions also, you should use 5 inputs. Okay, so give me those, I'll just give predictions. That is my single line agenda. Fine. Now whether you are giving while testing, okay, now my model is generated, right? So okay, so while testing, whether you are going to give the data from test data or again from training data or some other data, that is irrelevant for me as a model. Okay, my as a model, I'm only looking for some data, so that I will use my pattern recognition or algorithm, whatever I have inside me, to give some predictions. That's it. Now it is your choice whether you are going to, what type of data you are going to feed me, whether you are going to feed the completely new data from the customers, or the same data, the training data which you use for me to training, or you're going to give me that, or some other test data which you have kept some aside, or some other data. I don't worry about all those. Fine. I am only looking for some data to give some predictions. Is it clear, guys? Are we good? Are we good till this point?
One question, Santosh.
Yes, yes.
So you said like how much data we have you're used for training, the same amount of data we should use for testing.
No. I not say that. Okay. So, yeah, that's a good point. But what I said is features. Data is different, features is different. Data is rows. Okay.
Okay. Features. Okay, fine. Then,
Features.
okay.
Fine. So if you are using, see, while training, okay, see, that's a good point you mentioned. Okay, see, while training, let's say you are having X and Y. Okay, so in X, you might have like X1, X2, okay, X1, X2, X3. Simply, you have 3 inputs, okay, and one output will also always be 1. Fine. So this is my input and output. So over here, if you have like 1000 rows, okay, 1000 rows, right? That means what? Each of this row will have 3 inputs and output, 3 inputs, output, like that. You are having 1000 rows, 1000, okay.
Correct.
Now, while training, you can train with any data. Obviously, it is the more data you have, the better model you will have. Okay, 1000, 2000, 10,000. Okay, that's fine. Now the model is generated. Now on this model, whatever it is generated, let's say ML model is generated, fine. Now for the model, on this model to get some predictions, okay, you will pass only one record at a time, right? You will pass one record at a time to get some predictions, okay? That record should have all the required features, okay? That means whatever the test record you are passing, that should also have x1, x2, x3. You cannot pass only x1, x2.
Yeah, got it. Got it.
Got it? Or shall I take any example? Okay.
No, nothing.
Simple
Just I
example.
thought whether it's number of records, no, or what. I got it.
Understood. Okay. Just to give an example, let's say you're having sepal and sepal petal and petal, or IS dataset. Fine. So while training, you have used all these 4 columns to train. Agree? All these 4 columns are given train, and the output will be one of the 3 categories. Fine. Now while testing, also you should pass all these 4 columns. You cannot just pass these 2 columns and ask for predictions. Okay. So the number of features that are used while training should be same as number of features that you are going for testing also. Clear? Fine.
Yeah.
So now coming back over here. Now what I was saying, now the model that is generated, so now the model that is generated can be used, okay, now can be used for testing. Now the problem here is, if you have trained it on the training data, okay, and then you can use the same data for testing also. That means what? Testing the model, how well it has understood the training data first of all. Getting? So that means, first of all, I am training on a particular data, okay, how much pattern that it understood on my training data. Okay, because if it is not understanding the training data, how can I proceed for the testing data? Are you getting this?
Yes.
Repeat. I not get what you said, but two said at the same time.
Yes, sir.
Achha, okay, fine. Cool. See, we'll understand it very clearly. Okay, serious. Sorry. Serious. Okay, we're having ML model. In this data, initially, this data will be divided into 2 parts. One is training data, one is test data. Fine. Now, training data and test data, we have got it, right? So, what happens? I'm thinking whether we can we continue, guys, or is it becoming too much for you guys? Because too much might again confuse you guys. Okay.
Yeah. Kind of for me, it's like too much.
Okay, fine. It's okay. It's okay. There's no rush. Okay, we'll continue in the next class. That's fine. Okay, because I feel that we've discussed many concepts, general concepts. Okay, fine. So take some time, go through the class again. Okay, so we'll take this freshly. Okay, because I don't want to mix this particular topic with other topics. Okay, so the way how train data split is done, and what is because over here only you'll understand training accuracy, testing accuracy, and overfitting and underfitting. Okay, all of this. So this is a separate concept, which is very, very fundamental and very important concept. Okay, so understanding this, for me, basically, when I understood this, most of my machine learning concepts were clear. Okay, because everything will be coming from this. Okay, so because, see, if you understand this, you will understand train test split, you will understand overfitting, you will understand underfitting. Okay, then you will understand some other related concepts, which I will tell you. Okay, so that's why I don't want to mix this with other concepts. Okay, so I hope what all we have understood, it's clear. Okay, general concepts, fine. So take some time, go through the class again, just to have a revision on these general concepts, fine. And we will catch up in the next class. Okay, fine, guys. Thank you so much. That's all from my end.
Yes, sir.
Santosh.
Thank you.